Okay, this is the 2011 BCFRQ year. If you want to pull up the scoring rubric later. All right, so this is a cool one. Some different ideas, good mixtures, and it does have a volume in here. So I want to talk about this one because that could be on your exam. All right, so we got a function e to the 2x. That's the curve up there. We got a region R, and then it's walled off by a vertical line x equals k. So they're trying to scare you a little bit here in that they haven't given you like 7. They're giving you a varying right edge here. So A says write, but do not evaluate an expression involving an integral that gives the perimeter. So this was the first time they'd ever done this, and it kind of threw a lot of people off. Perimeter, think back to middle school when you learn about perimeter. It's just your distance all the way around. So instead of being typical, so like your entry-level calculus question would have just said, hey, what's the arc length? And they would have asked you what that length is, the green line. Instead, they make it one little step more, and they say, well, I want to know the whole perimeter, meaning it's not just the green line, but it's also the yellow line and this pink line. I don't have another color. And this purple line. You got to have all of those pieces for perimeter. Remember, perimeter is the distance around. So perimeter, go piece by piece. So that yellow line is a length of 1. Because that's just how tall it is, 1. The purple line on the bottom is k. So from 0 to the pink line is k units. And then the pink line, that's the height there, is e to the 2k. All right, so this is the yellow thing. This is the pink thing. That's the purple thing. And then the green part is your integral. So the green part is your arc length. So you got to know the arc length formula. So it's the integral from 0 to k of the square root of 1 plus the derivative squared. So remember your formula is this. It'd be dy dx, quantity squared dx. So the derivative of e to the 2x here is going to be 2e to the 2x. And I would leave it literally just like that. Don't try to simplify it. There's no point in doing that. Points wise, this would probably be worth 3 points. I think correctly getting that derivative would be worth 1 point. I think probably this integral would be a point. And then I think like the whole thing would be a point. 3 points. All right, what they didn't ask here would be area. So they had said, hey, find the area of region R. Remember, area is just your integral from 0 to k of the top curve, which is f of x, minus the bottom curve, which is 0 dx. So with area, you're not squaring anything. So that's just plain old area, top minus bottom. It's 2 dimensions in that this is 1 dimension and this is your other dimension. So this times that is your areas, and then you're adding up a whole bunch of them. They didn't ask that question. All right, question B says, all right, well, now I'm going to spin this thing. All right, so I'm going to spin it around the x-axis. So when I spin this thing around the x-axis, and this is going to be a disk method because it's solid, there's no empty space. So it's going to be the integral from a to b of the radius squared dx with a pi out front, pi r squared. Because pi r squared is the area of one circle slice, and then the dx is what makes it a volume. So my radius is the curve to the center of revolution. So this becomes pi from 0 to k of e to the 2x squared. And if you wanted to do minus 0 squared dx. So it's the top of that pink purple line to the center of revolution. find the volume. So you actually do, it actually wants you to find the volume here to work it out. So we got pi. Simplify it once. 0 to k, so it's e to the 4x dx. Antiderivative. So remember, you gotta like reverse chain rule it. So it's 1/4 e to the 4x 0 to k. So you got the pi over 4 out front. So pi over 4 e to the 4k minus pi over 4. There's your volume. Remember, k is a constant, so that's just a number. So that's the volume. So that would be B, full credit. I think that's probably worth 4 points. Probably 1 point for the integrand. It was 1 point for the correct limits. It was 1 point for the correct antiderivative, and then it was 1 point for your answer. So that was out of 4. All right, part C says, well, the volume changes as K changes. So think about it this way: as if K got bigger, then your volume is going to be growing. Like what you have here, if you were to go draw, I remember we used to draw these things. I wasn't very good at it, but y'all were worse. So as K gets bigger, this thing gets taller. It's like a mountain sideways. I just turned mine sideways, but you didn't see that. So if you thought of it sideways, it'd be like this mountain is growing. So as K is increasing, this mountain that I'm making is growing, or as K is getting smaller, it's getting smaller. So they just made this a related rate. It's kind of different. dk dt equals 1/3. So I need to introduce time to this. So if I know the volume is pi over 4 e to the 4k minus pi over 4, and we got that from part B. Well, if I need this in terms of time, you got to differentiate it in terms of time. It's a related rate. So that becomes the change in volume over time. Got to take your derivative. So the 4 is going to come down, so it becomes pi e to the 4k, and it's dk dt, because you're doing it with respect to k, or with respect to time. And then the derivative of pi over 4 is just a 0. All right, so now I've animated this. They told me that dk dt is 1/3, so I know this. And they told me that k is 1/2, so I know that. So if you think about it, you know everything now. So the changing volume at time is pi e to the 4 times 1/2 times 1/3. And you could stop right there if you wanted to simplify it. It'd be pi over 3 e squared. One thing I want to talk about, so that's it, and that would be a 2-point problem overall. One twist they didn't do, but say they had wanted you to find the volume, and they wanted to make it a washer method. So what we're going to do is we're going to spin this thing around the line at y equals -1. So that means there's a gap. So if you spun this thing, it's like someone drilled a hole down the middle of this mountain. So now it's a volcano on its side. So remember, the washer method is pi integral a to b of big R squared minus little r squared dx in this case. So up here, so the outer radius is the furthest from the center of revolution to the center of revolution. And then the inner radius is this smaller one to the center of revolution. So it'd be pi integral from 0 to k. This is if I spun around y equals -1. And then the big R would be the outer curve, which is f of x minus your center of revolution, which is -1 squared. And then the little radius is going to be 0. That's the equation for the x-axis, minus -1 quantity squared dx. And you could leave it like that. I would probably put pluses instead of minus, but that would be your final answer. So that's your washer method. So that's when you spin something and revolve it and there's a hole in the middle. Remember, to write down this. That will help you get your setup correct.